In the figure, angle MEO is the exterior angle of triangle MGE, whose two remote interior angles are angles M and G. If we try to add the measures of the two remote interior angles, the sum is 120 degrees. And if you try to compare the sum of the measures of the two remote interior angles to that of the measure of the exterior angle, they are actually equal. And that is what exterior angle theorem states. It states that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Let's apply the exterior angles theorem in the following examples. If the measure of angle RTQ is 84 and the measure of angle RQT is 45, let's find for the measure of angle SRQ and the measure of angle QRT. Let's find first for the measure of angle SRQ. Angle SRQ based on the figure is an exterior angle whose two remote interior angles are the two given angles, which are angles RTQ and RQT. Therefore, the sum of these two remote interior angles is equal to the exterior angle, angle SRQ. By substitution, we substitute the given to our formula. We have angle RTQ is 84 and angle RQT is 45. So by substitution, we have the measure of angle SRQ is equal to 84 plus 45, and their sum is 129. Therefore, the measure of angle SRQ is equal to 129. We are done solving for the measure of angle SRQ. Therefore, we are now ready to find for the measure of angle QRT. Angle QRT is an interior angle adjacent to angle SRQ, which is an exterior angle. By definition, if an exterior angle and an interior angle are adjacent, then these two angles are supplementary since they form a linear pair, meaning their sum must be 180 degrees. So the measure of angle QRT plus the measure of angle SRQ then is equal to 180. By substitution, since we already have solved for the measure of angle SRQ, we now substitute 129 and it becomes measure of angle QRT plus your angle SRQ is 129 and we equate it to 180. By addition property of equality, we have, or by transposition, we have the measure of angle QRT is equal to, we just need to copy 180, then we transfer 129 to the right, it becomes negative 129. Subtracting 129 from 180, our difference would be 51. So the measure of angle QRT is 51. We now proceed to the second example. If the measure of angle RTU is 112 and the measure of angle QRT is 76, let's find for the measure of angle RQT and the measure of angle RTQ. Let's find first for the measure of angle RQT. As you can see on the figure, angle RTU, this angle is an exterior angle whose two remote interior angles are angle RQT, which is the unknown, and angle QRT, which is 76. Then we have the formula, the measure of angle RTU, which is the exterior angle, is equal to the sum of the measures of the two remote interior angles, which are angles QRT and RQT. By substitution, we have to substitute now the given to the formula. We have the measure of angle RTU is 112 and the measure of angle QRT is 76. So we have 112 is equal to 76 plus the measure of the unknown angle, which is angle RQT. By addition property of equality or by transposition, we just need to copy 112, then 76 will be moved to the left. It becomes negative 76. Then we just need to copy the measure of angle RQT. The difference of 112 and 76 is the measure of angle RQT, which is equal to 36. So the measure now of angle RQT is equal to 36. We are now ready to solve for the measure of angle RTQ. Angle RTQ is an interior angle adjacent to the exterior angle, which is angle RTU. Angle RTQ and angle RTU form a linear pair. Since they form a linear pair, then we can say that they are also supplementary. Since the sum of the measures of supplementary angles is 180, then we can come up with the formula measure of angle RTQ, which is the interior angle, and the measure of angle RTU, which is the exterior angle adjacent to angle RTQ. Their sum would be 180 since they are supplementary. Since we are given the measure of angle RTU as 112, we are now ready to solve for angle RTQ. So by substitution, we have the measure of angle RTQ plus the measure of angle RTU is 112. Then we equate it to 180. By addition property of equality, we just need to copy the measure of angle RTQ. Then we move your 112 to the right. It becomes negative 112. Then our equation would become measure of angle RTQ is equal to 180 minus 112. Their difference would be 68. This permits us to have the measure of angle RTQ as 68. We now have the third example. If the measure of angle RQT is 64, the measure of angle QRT is 54. Let's find the measures of the following unknown angles. We now solve for the measure of angle RTQ. Angle RTQ actually is an interior angle. It's an unknown interior angle wherein the two other interior angles are given, which are 64 degrees and 54 degrees. In the triangle angle sum theorem, which states that in every triangle, the sum of the interior angles is 180 degrees. This theorem would help us to solve for the measure of these unknown interior angles. Since the sum of the measures of the interior angles of any triangle is 180, then we need to add the three measures, then we equate it to 180. So the measure of angle RQT is given, which is here. The measure of angle RTQ is the unknown, and the measure of angle QRT is also given. So we have the measure of angle RQT is equal to 64. The measure of angle RTQ is the unknown, we just need to copy. And the measure of angle QRT is 54. And then we equate it to 180. Adding 64 and 54, the sum is 118. Copy measure of angle RTQ, we equate it to 180. Then by addition property of equality or by transposition, we just need to transfer 118 to the right. It becomes negative 118. Then we just need to get their difference. Then our answer would be 62. So the measure of angle RTQ is 62. We now have the measure of angle PQT. Angle PQT is actually an exterior angle whose two remote interior angles are angles QRT and QTR, these two angles. Since the two remote interior angles of angle PQT are already known, then we can now solve for the measure of this exterior angle, angle PQT. By exterior angles theorem, we just need to add the measures of the two remote interior angles and equate them to the measure of the exterior angle. So the exterior angle is the unknown, which is the measure of angle PQT, which is now equal to the measure of angle QRT based on our given is 54, and the measure of angle RTQ is 62. So we have the equation measure of angle PQT is equal to the measure of angle QRT, which is 54, and the measure of angle RTQ, which is 62. Adding these two measures, their sum is 116. That is now the measure of our exterior angle. Measure of angle PQT is 116. We proceed in solving for the measure of angle SRQ. Angle SRQ, this angle is also an exterior angle whose two remote interior angles are 64 degrees and 62 degrees in measures. By exterior angle theorem, we can have this formula, the measure of angle SRQ, which is the exterior angle, equals the sum of the measures of its two remote interior angles, which are angles RQT and RTQ. By substitution, we have the measure of angle SRQ is equal to the measure of angle RQT is 64 and the measure of angle RTQ is 62. Adding these two measures, the sum is 126. Therefore, that is now the measure of angle SRQ. We now proceed in solving for the measure of angle RTU. Angle RTU, based on the figure, is also an exterior angle whose two remote interior angles are known, which are 64 degrees and 54 degrees in measures. Since the two remote interior angles are already known, then we can now apply the exterior angles or exterior angle theorem in solving for the measure of this exterior angle RTU. So we have the formula measure of angle RTU, which is the exterior angle, is equal to the sum of the two remote interior angles, which are angles TRQ and RQT. By substitution, angle TRQ is 54, TRQ is 54, and angle RQT is 64. Then, their sum is 118. Therefore, the measure of angle RTU is 118. Let's use this figure in finding for the value of x, the measure of the exterior angle, the measures of the two remote interior angles, and the measure of the angle adjacent to the exterior angle. We are given measure of angle B as 4x plus 2, the measure of angle F as 3x plus 14, the measure of angle BDC, which is the exterior angle, as 9x minus 14. So all we need to do first is to formulate a formula or to make a formula in order for us to successfully or correctly solve for the value of x. So the exterior angles theorem once again states that the measure of the exterior angle is equal to the sum of the measures of its remote interior angles. So based on the figure, angle BDC is the exterior angle and its two remote interior angles are angles FBD, this angle, and angle BFD, this angle. So we can have the formula measure of angle BDC, which is the exterior angle, is equal to the sum of its two remote interior angles. The two remote interior angles once again are angle DBF, this angle, and angle BFD, this angle. So by substitution now, we have measure of angle BDC, which is the exterior angles, is 9x minus 14. We have here 9x minus 14. And then the measure of angle DBF, DBF is 4x plus 2. That is 4x plus 2. Plus the measure of angle BFD, this angle, it's 3x plus 14. So by combining like terms, we have 4x plus 3x is equal to 7x. 2 rather, plus 14 is equal to 16. So we have copy 9x minus 14 equals 7x plus 16. By addition property of equality, we just need, or by transposition, we just need to copy here 9x Then transpose 7x, we transfer it to the left, it becomes negative 7x. Copy 16. Then our negative 14 will be transferred to the right, it becomes positive 14. So by simplifying, 9x minus 7x is 2x and 16 plus 14 is 30. Dividing both sides the equation by 2 in order for us to solve for the value of x, our answer would be 15. So the value of x now is 15. Let's now find for the measure of the exterior angle. Based on the figure, our exterior angle is angle BDC. And angle BDC as given is equal to 9x minus 14. Here is angle BDC, 9x minus 14. By substituting the value of x to the variable x in the equation, we have 9 times x is 15 minus 14. 9 times 15 is 135, less 14 is 121. Therefore, the measure of the exterior angle is 121. The third one is to solve for the measures of the two remote interior angles. The first remote interior angle that we need to solve is angle DFB, this angle. So we have the measure of angle DFB is equal to 3x plus 14. Substituting once again the value of x to the variable x in the equation, we have 3 times 15 plus 14. 3 times 15 is 45 plus 14 is 59. So the measure of one of the remote interior angles, which is the measure of angle DFB, is 59. We now proceed in solving for the measure of the other remote interior angle, which is angle FBD. The measure of angle FBD based on the given is 4x plus 2. So we have the measure of angle FBD is equal to 4x plus 2. Then the value of x is once again 15. We substitute that value of x to the variable x in the equation. We have 4 times 15 plus 2. 4 times 15 is 60 plus 2. The measure of angle FBD then is equal to 62. We now solve for the measure of the interior angle adjacent to the exterior angle. Based on the figure, the interior angle adjacent to the exterior angle is this angle. We have angle BDF. So angle BDF and angle BDC, which is the exterior angle, form a linear pair. Therefore, they are supplementary. Their sum is equal to 180 degrees. So we have to add the measures of angle BDF and angle BDC and we equate it to 180. That becomes measure of angle BDF plus the measure of angle BDC is equal to 180. Measure of angle BDF is the unknown. Measure of angle BDC is already known, which is 121. We equate it to 180. By transposition or by addition property of equality, we transfer 121 to the right, it becomes negative 121. So the difference of 180 and 121 is 59. The measure of angle BDF then is equal to 59. The measure of the exterior angle in the given figure is 120 degrees. The measures of the two remote interior angles are both 60 degrees. As you can observe, the measure of the exterior angle is always greater than any of the measures of the two remote interior angles. And this is what exterior angle inequality theorem states. It states that if an angle is an exterior angle of a triangle, then its measure is greater than the measure of any of its corresponding remote interior angles. Based on the figure, the longest side is segment WO and the shortest side is segment WT. In the theorem, the longer side is opposite the larger angle, or in other words, the longest side is opposite the largest angle. Therefore, we have angle T as the largest angle since that is the opposite of the longest side, which is segment WO. Since angle O also is the opposite angle of the shortest side, which is WT or segment WT, then we can say that the smallest angle is angle O. And in the theorem, it also states that if two sides of a triangle are not congruent, so as you can see, segment WT and segment WO are not congruent, then the angles opposite them are not also congruent. As you can see once again, angle T is the largest angle, angle O is the smallest angle, therefore they are not also congruent. This theorem is just an opposite of the previous theorem. If two angles of a triangle are not congruent, then the sides opposite them are not congruent, and the larger angle is opposite the longer side. In the figure, since angle N is 75 degrees and that is the largest angle, the side opposite this angle is actually the longest side, which is segment OE. The smallest angle is a 45-degree angle, which is angle E, and the side opposite this angle is the shortest side, which is segment NO or segment ON.